Okay, thanks for that. Before that, I'll just make a few points on some of the possible impacts of 1.5 versus 2 degrees on biodiversity. And there's a whole parallel session this afternoon that will explore this in more detail, but I wanted to just make a few points. Firstly, it's important to remember that to date, and probably into the near future at least, habitat loss is the primary cause of biodiversity decline and loss. And climate change will become increasingly important in the future, but we must remember that the major role that habitat loss plays. And so if we're looking at the impacts of 1.5 versus 2 degrees, I think we can broadly divide the world's ecosystems into two categories. There are those which may be potentially close to some sort of threshold or tipping point, where there would be habitat loss caused by warming of approximately 2 degrees. And example candidates could be coral reefs, there could be isolated mountaintop ecosystems, low-lying island ecosystems. And there's a potential of a significant gain being achieved by keeping warming to 1.5 degrees. But many other systems, the majority of the world's ecosystems, are probably still in the linear range, 1.5 to 2 degrees. So while there haven't been specific studies of 1.5 degrees, we can reasonably guess that the impact of 1.5 degrees in the medium term would be about 3/4 of the impact of 2 degrees. And there we have a more interesting challenge, because as Pete highlighted, there are potential trade-offs in how we achieve 1.5 degrees. If those trade-offs involve extensive increase of land use pressure on critical ecosystems, and that could be direct land use pressure, or it could be through economic teleconnections, where land use changes in other parts of the world and changes demand in biodiversity-sensitive issues, then there could be potential losses in biodiversity caused by an overzealous and unthinking mitigation pathway that takes us to 1.5 degrees. And we have to be aware of those risks. But conversely, there are also potential win-win situations where we have well thought through biosphere management, rehabilitation of the biosphere that gives us mitigation benefits while also improving the biodiversity prospects for the biosphere. So we need to think of where there are possible dangerous trade-offs and where there are potential win-win scenarios. And the final point I'll make is that most biodiversity doesn't respond immediately to either climate change or habitat loss. There's often a lag on the scale of decades or centuries. Often things are said to be committed to extinction under fragmentation or climate change. And therefore, what matters in terms of climate change is not only the immediate target, but the pathway beyond that target. If we see that the climate pressure reduces over time, so below 2 degrees, below 1.5 degrees, much of biodiversity may be more resilient than we think if we can get temperatures down by the end of this century. So we might need to think about not the end point of 1.5 or 2, but the pathway beyond that into the century beyond in terms of the resilience of the biosphere. So I'll end there.
Okay, cheers. Thank you. Radvinda. Okay, we already have our first question from agriculture, but do we have some more? We have one question. Why don't we take the two there, and we'll answer them at once. Cheers. Can you get the microphone in?
Thank you for some very interesting presentations. I have two questions. So the first one is, as Pete also presented, the problem is with...
Just ask one.
Yeah. Oh, right. Okay. That's fair enough. With forestry, is that it's presented as the numbers are net, which in my, the issue is really it's hiding both the true problem, the actual problem with forestry, deforestation, and also the true mitigation potential of actually dealing with it. And that's something we've really been looking into as well, is, first of all, if you deal with deforestation, then you actually have pretty large sinks potential as well. If you look at reforestation and ecosystem restoration afterwards, which also has the co-benefit of improving biodiversity. So I was interested to see whether you have some thoughts about, what is the actual potential, maybe even in some numbers, because if we have to have negative emissions at some point, there might be one way of dealing with it.
Pete, your question about 250 gigatons of negative emissions, do you think, given all the land use, sustainability, economic impacts of doing that 250 gigaton figure is something that we should rely on, or should it be much lower in total global carbon budget terms?
Okay, can we have one more? Let's have one from Corinne, please. And we take those, and then we take also the one.
Thank you. Just first a note of caution about the word negative in negative emissions, because it's going to be really difficult in terms of acceptability for the negative emissions technology. And so if we take evil carbon dioxide out of the atmosphere, put it on the ground and call it negative, we're not really helping ourselves. So maybe carbon removal technologies would be a little bit more useful in terms of acceptability. But my question really relates to overshooting. So what if we overshoot? Is it better from a biodiversity perspective to overshoot the 1.5 degree and come down? Or if we've committed to a temperature, then we stabilize at that temperature? And to me, it's not really clear whether there is information on this or not.
Okay, so let's take those.
Okay, yeah, so I can take those two questions together. I think that, firstly, the paper that we originally put into Nature Climate Change was framed around don't rely on negative emissions because, there are a number of potential adverse implications, and the risks go up and the costs go up if they don't come into fruition. So it was originally framed in those terms. When 1.5 came on the agenda, then I think even with maximum rapid aggressive mitigation, we're probably going to be left with something that we need to do in terms of negative emissions. So the reason I thought that it wasn't off topic was to talk about this, because if we head for 1.5 rather than 2, that's probably going to imply more negative emissions with all of those consequences associated with land use. So I think that it's something that's, I think it is achievable, but it's going to have consequences. We need to look at all of those different consequences and how they interact, not just with biodiversity, but with food production, the climate system, et cetera, et cetera. Sonia made a good point about the feedbacks between the way we change the land and the regional climate. But we're probably going to need some negative emissions. So in my personal opinion is that we need to invest money into demonstration projects for each of these technologies to see which ones have legs. So some of them may and some of them may not help us in the future. But if we leave it until 2030 before we start to develop them, it's too late. We need to start to develop some of those now, investing in those sorts of technologies so that we can see what we do. And most importantly, aggressively and immediately reduce greenhouse gas emissions as fast as we possibly can.
Okay. Do you want to say anything? Or should we go on? You can make.
I think on the point of overshoot, the critical thing is the risk we take of hitting critical thresholds or tipping points. So we need to, the higher the overshoot, even if there's a lower target in the end, the higher the risk that we'll hit some thresholds that we're either haven't quantified well or unaware of. So that's a big risk there. And I think carbon removal is important for the last point I made earlier on, which is for biodiversity security, we actually need to think about CO2 and greenhouse gases going below on the century time scale, even below the maximum target value. And we need some sort of negative or carbon removal approach to achieve those goals.
Yeah, okay, good. Cheers. Okay, let's open up for some more exciting questions. Let's have one here and one here and one there.
First word of thanks, both for the oceans, and I'm sorry it said noting in the preamble. We tried to get it even stronger, but thank you for that work. Also for your stress on human behavior. And I hope that in the next 2 days we are able to talk more about this. We are able to encourage more studies on this. One of the things we find in our work as a non-scientist is people say, well, what is the effect if I do that? Show me, prove it to me before I agree to do that. So as much as that can feed into particularly the AR6, we encourage more studies on this. Thank you.
Cheers. We had one down here.
Thanks. With biodiversity and ecosystem impacts, some of the biggest impacts are from extreme events. But we've already heard it's rather hard to distinguish the difference in extreme events between 1.5 and 2. Is this a problem we can actually resolve in terms of projections or at least anticipation?
Very good question. Okay, and one right down the front, if you could just pass it forward using your own skills. Henry, too.
Thanks. Andreas, you showed that we know surprisingly little about the potential for collapse in the ecosystem that accounts for 2/3 of the planet and most of the planet's biomass, which is actually quite shocking, and particularly from multiple stressors. And you said this was a plea for help from the climate community. What help does the oceans community need from the climate community to figure out this vital question?
Okay, good. Do you want to ask one as well, Miles? Go on.
I just wanted to ask all the speakers about early warning indicators and how far in advance would we be able to detect these thresholds being crossed? Because obviously that has important implications for remedial measures like negative emissions.
Okay, that was a very good question too. Okay, so let's have
Okay. Two questions and a very quick remark to your opening remarks about habitat loss and extinction. I mean, it's true. It's very interesting. If you look at the sort of anthropogenic extinction period that we're in, a disproportionate part of the species that are going extinct are endemic species, and they're going extinct because of local habitat loss. And that's fundamentally very different from previous extinction events where you had global species going extinct. And they went extinct because of fundamental changes in chemistry and sort of life-giving processes, mostly photosynthesis, right? That starts in the water. That's an ocean phenomenon. That's why this experiment we're doing with the ocean is so terrifying to me, right? It has driven extinction events in the past that have been far more terrifying than anything we're seeing right now. As to the 1.5 to 2 difference in oceans, the problem with the ocean is the signal and the noise problem is huge. For us to get to within sort of 1 sigma confidence on changes in the ocean, stripping out climate effects between the national variability of the ocean, it often takes a decade or 2. That's why I think we really need to shift from that kind of science, not shift from, but in addition to doing that kind of science, we need to do the connective science and saying not just what is going to happen, factor A and factor B, but what actually happens if you take all the linkages into effect to the stability landscape of the entire system. We cannot wait in the ocean to get good statistical separation of what will happen at 1.5, 2.0. It's going to take, structurally, it takes decades to do so, and we don't have that. We don't have that kind of time. The help from the climate community that is needed. I think we need to really diversify the efforts, and it's much like in the financial community where the federal bank builds a gigantic equilibrium model, and then but a lot of the economics is driven by very specific small models to solve very specific questions, such as time to default on a credit portfolio or whatever. The same thing needs to happen here. We need to get very comfortable with very specific modeling efforts about destabilization risks and hooking those together. The input and the communication between the ocean modelers, developing those, the folks that are knitting all those together into an overall landscape of risk, and then feeding that back into the great picture of Earth systems and climate risks has to become a lot smoother. There was an earlier acknowledgement that ocean risks are probably systematically underrepresented today in our Earth systems modeling, and that has to stop. The oceans really, I think, are in the center of it.
Yeah, good. Shall we answer questions on early warning indicators? Or?
Okay, indicators?
Indicators? Yeah, I'll just respond to Miles's point. I think potentially we can see early warning indicators. Some of the work that we've done in the Amazon from a variety of sources over the last 20 years has shown firstly that forests were responding to possibly higher CO2 by increasing in biomass, but this response is declining over time and we're seeing changes in biodiversity. But a key thing that comes from that actually is we need a monitoring system to be able to look for these indicators over time. And imagine if where the science of climate change would be if we had no worldwide weather observation network to actually give us the empirical data. But we're like that in terms of biological systems. We don't have a global ecological monitoring system that gives us coherent data on the state of the biosphere. And that is something I think that needs to be a priority over the next few decades, to get this early warning system in place across the terrestrial biosphere.
Great. And what about you, Pete? Do you want the very final word before we go for coffee?
No.
Okay, well, okay, in that case, I'd like to thank the panelists and the speakers very much. Thank you very much.